When we gaze upwards on a clear night, away from the city lights, we are met with an astonishing spectacle. The universe unfolds above us, a canvas of glittering stars and distant, ethereal galaxies. It is a place of unimaginable scale, stretching further than our minds can comfortably grasp. This cosmic arena is home to everything we know, every planet, every star, and every form of matter and energy. The sheer vastness is humbling, making our own world seem like a tiny speck in an immense ocean of existence. Understanding this universe, its origins, its structure, and its ultimate fate is one of humanity's oldest and most profound ambitions, driving our curiosity to explore the unknown. This leads us to one of the most fundamental questions we can ask about our cosmic home. Is the universe truly endless? Or does it have some kind of boundary, a limit beyond which there is nothing more? Imagine traveling in a spaceship in a straight line forever and ever. Would you eventually come to an edge, a cosmic wall? Or could you travel indefinitely, always finding more space, more galaxies, stretching into infinity? This question isn't just an abstract thought experiment. It touches upon the very nature of reality and our place within it. The answer has profound implications for our understanding of cosmology and the fundamental laws that govern existence itself, shaping our perception of the cosmos. Attempting to answer this question is an immense challenge, primarily because our ability to observe the universe is fundamentally restricted. We are, in a sense, looking out from a specific point in space and time. And there are limits to how far our instruments, no matter how powerful, can actually see. These limitations are not just technological. They are woven into the very fabric of the cosmos and the laws of physics that govern it. Therefore, directly observing an edge, if one even exists in a conventional sense, is an incredibly complex proposition. Scientists must rely on indirect evidence, mathematical models, and theoretical frameworks to even begin to approach this monumental query. The pursuit of this knowledge speaks volumes about our innate desire to understand. The universe doesn't just contain us, it defines the very context of our existence. Wondering about its potential infinity or finiteness reflects a deep human need to comprehend the boundaries of our reality, or the lack thereof. It's a question that sits at the intersection of science, philosophy, and even art, inspiring awe and contemplation. Whether it stretches on forever or is somehow contained, the universe remains a source of endless fascination, prompting us to constantly refine our theories and push the boundaries of our understanding, exploring what lies beyond our immediate perception. Our primary tool for exploring the universe is light, or more broadly, electromagnetic radiation. However, light travels at a finite speed, approximately 299,792 kilometers per second. While this seems incredibly fast to us, the universe is so vast that it takes light a very long time to traverse cosmic distances. This means when we look at distant objects, we are seeing them as they were in the past, not as they are right now. This speed limit imposes a fundamental boundary on what we can observe. There's a sphere around us, known as the observable universe, which contains all the light that has had time to reach Earth since the universe began, roughly 13.8 billion years ago. The observable universe is estimated to be about 93 billion light-years in diameter. This is an almost incomprehensibly large distance. It's important to understand that this doesn't necessarily mean the universe ends at this boundary. It simply marks the edge of what we can currently detect from Earth due to the finite age of the universe and the constant speed of light. Beyond this cosmic horizon, there could be much more universe, perhaps an infinite amount, but its light simply hasn't had enough time to travel all the way to us. So, the observable universe is like our cosmic neighborhood, but the entire city, or even country, could be much, much larger still. Now let's consider what an endless or infinite universe would truly mean. If the universe is infinite, it would stretch on forever in all directions. This implies an infinite amount of space, an infinite number of galaxies, stars, and planets. It's a concept that can be quite difficult to wrap our minds around. In an infinite universe, any configuration of particles that is physically possible would likely occur somewhere, perhaps an infinite number of times. This has some mind-bending philosophical implications, suggesting that somewhere out there, incredibly far away, there could be other Earths, or even exact copies of ourselves, a consequence of infinite possibilities playing out across an endless stage. Conversely, what if the universe is finite? A finite universe would mean that it has a specific measurable size, although it might not have an edge in the way we normally think of one. Imagine the surface of a sphere, like the Earth. It's finite in area, but you can travel on its surface indefinitely without ever reaching an edge or falling off. You would eventually return to your starting point. Some cosmological models propose that the universe could be shaped like this, finite but unbounded. If it did have a true edge, that would raise the even more perplexing question of what lies beyond that edge, a concept that challenges our very definitions of space and existence. Our current best scientific understanding of the universe's origin and evolution is the Big Bang theory. This theory doesn't describe an explosion in pre-existing space, but rather the expansion of space itself from an incredibly hot, dense state. Around 13.8 billion years ago, all the matter and energy in the observable universe were concentrated into an unimaginably small region. From this singular point, the universe began to expand and cool, leading to the formation of atoms, then stars, and eventually galaxies. The Big Bang theory is supported by a wealth of observational evidence, including the cosmic microwave background radiation and the observed abundances of light elements. Shortly after the Big Bang, a period of extremely rapid expansion known as cosmic inflation is thought to have occurred. During this incredibly brief fraction of a second, the universe is theorized to have expanded exponentially, ballooning in size by an enormous factor. If inflation did happen, and the evidence for it is quite compelling, it means that the actual universe, the totality of everything, could be vastly, vastly larger than the part we can currently observe. Inflation could have stretched the universe to such an immense scale that for all practical purposes, it might appear effectively infinite to us, even if it is technically finite but just unimaginably huge. Scientists continue to debate the overall geometry and ultimate size of the universe. According to Einstein's theory of general relativity, the presence of matter and energy can curve space-time. The universe can have one of three possible shapes: flat, like a sheet of paper, positively curved, like the surface of a sphere, or negatively curved, like a saddle. Current measurements from missions like the Planck satellite suggest that the universe is very close to flat on the largest observable scales. A flat universe, if it extends indefinitely, would be infinite. However, even a flat universe could be finite if it has a more complex topology, like a torus, a donut shape. It's crucial to remember that the Big Bang theory describes the evolution of the universe from that very early, hot, dense state. It tells us about its expansion and cooling and the formation of structures we see today. However, the theory itself doesn't definitively answer whether the total universe is finite or infinite. It describes the observable patch that emerged from that initial event, but doesn't inherently set a boundary on the entirety of existence. The question of what, if anything, the universe is expanding into is also a complex one, as the expansion is understood as space itself stretching, rather than galaxies moving through a pre-existing empty void. One of the most remarkable discoveries of the 20th century was that the universe is not static, it is expanding. Astronomers like Edwin Hubble observed that distant galaxies are moving away from us, and the further away they are, the faster they appear to be receding. This phenomenon, known as Hubble's law, is key evidence supporting the Big Bang model. It's not that galaxies are flying through space away from a central point, but rather that the fabric of space itself is stretching, carrying the galaxies along with it, much like dots on an inflating balloon move apart from each other as the balloon gets bigger. This expansion has significant implications for the question of whether the universe is endless. If space itself is expanding, it becomes more challenging to define a fixed edge. If the universe is infinite and flat, then it will continue to expand forever, becoming ever larger and more dilute. If it is finite and closed like a sphere, its expansion could potentially slow down, halt, and perhaps even reverse, leading to a big crunch. Although current evidence for accelerating expansion driven by dark energy makes this scenario less likely. The ongoing expansion pushes distant regions of the universe beyond our observable horizon faster than light can reach us from them. So, is the universe truly endless? The honest answer is that we still don't know for sure. Scientists are actively working on this question, using sophisticated telescopes, analyzing the cosmic microwave background radiation in minute detail, and developing ever more complex theoretical models. Each new piece of data helps to refine our understanding and constrain the possibilities, but a definitive answer remains elusive. The The universe we can see is vast, but it might only be a tiny fraction of the whole. The true extent of reality could be far grander and more mysterious than we can currently imagine, perhaps even infinitely so. The quest to understand the universe's ultimate scale is a testament to human curiosity and our relentless drive to explore the cosmos. While we may not have the final answer today, the journey of discovery itself is incredibly rewarding. Each observation, each theory, brings us a little closer to comprehending our place in this magnificent and perplexing universe. The search continues, fueled by the wonder of what lies beyond our current understanding, pushing the boundaries of knowledge. Perhaps one day we will know whether we live in a finite cosmos or an endless expanse. But until then, the mystery itself inspires us to keep looking up and asking the biggest questions.